All right. Today we're going to talk about writing linear equations given a verbal description. Number one, miners are exploring 90 feet underground. The miners ascend in an elevator at a rate of 30 feet each minute until they reach the surface. Write the function that represents the distance in feet of the miners. Okay, so let's talk about the fact that when we talk about linear equations, we know we're talking about either standard form, slope-intercept form, or point-slope form, depending on how the situation is written. Normally, when we look at a word problem, we'll probably write it in either standard form or slope-intercept form. And I know you've heard these words before. I hope that you remember what they look like. So let's write them out. Slope intercept form, right, is y equals mx plus b. Standard form is ax plus by equals c. All right, so these are our two forms. 1, 2. We might need point slope form, but 9 times out of 10 we won't. So we'll leave it like this. So when we read this problem, first off, we have in every problem, there's an X and a Y, meaning an input and an output, an independent variable and a dependent variable is what we say. All right. So when we read this problem and it says the miners ascend in an elevator at a rate of 30 feet each minute, right? This is all about the slope. What says it's the slope? First off, it says it's the rate, right? And then after that, it says 30 feet each minute, right? Whenever we see each, per, anything, that's all slope, right? And whatever it says, if it says each minute, then the minute is our x, right? If it says per second, then the second, is our x. So in this situation, what we want to do is identify our minutes as our x. And then when we come down here to the question, what it's telling us to do, write the function that represents the distance in feet of the miners. Well, distance is our y. This question is telling us our y. All right. We know our slope now. But now it's like, okay, what's the y-intercept? Well, let's read it again because now we can read it with fresh eyes. All right. Whenever we deal with word problems, we may have to read it a time or two. All right. So let's read again. Miners are exploring 90 feet underground. Underground. Okay. The miners ascend in an elevator at a rate. They come up out of the ground at a rate of 30 feet each minute until they reach the surface. Write the function that represents the distance in feet of the miners. Okay. Cool. Well, one thing's for sure. We're going to be dealing with slope-intercept form. And you may say, how do you know? Well, if we look at this problem, it gives us the slope, right? So it's probably slope-intercept form if the slope is given. So let's write our model. Y equals mx plus b. Well, we know our y is distance equals our slope, which is 30 feet per second. So what's the y-intercept? Meaning, what's our starting point, right? So we might want to start thinking of our y-intercept as our starting point, all right? Think of it as our starting point, all right? We need to start thinking that way in word problems. Well, it looks like they started 90 feet underground. And since it was underground, below surface level, we need to write subtraction here. And we're going to write subtract 90. So the distance is, equals means is, 30 feet per second minus 90. So they start at negative 90 and they come up 30 feet each second. Okay, I'm going to add a twist to it, right? This is it. This is our answer right here. We need to go no further. Here's our equation. But the question is, how many seconds might it take them to get to surface level, right? Don't answer it. It's just a thought, right? All right, let's go to number 2. It says the appropriate distance in miles between Los Angeles and a commercial jet flying from Boston to Los Angeles is 2,650 miles. All right. The jet is flying 475 miles per hour. Write an equation to represent the distance left on the flight. All right, the distance left on the flight. All right, we got quite a bit here in this information, right? Remember, we always got to determine an X, a Y, right? And we see this 75 miles per hour. Whenever we see per, each, that's telling us the slope. So we can go ahead and identify this is our slope. Right? So what's our X? Because if we find the slope in a word problem, the X is not far away from it, right? So this per hour, right? That's our X, hours. All right, then it says the appropriate distance in miles between Los Angeles and a commercial jet flying from Boston to Los Angeles is 2,650 miles. All right, cool. And the jet is flying 475 miles per hour. Write an equation to represent the distance left on the flight. All right, so when we start the flight, how many miles do we have to go? 2,650, right? This is our y-intercept, people. This is our y-intercept. Because it's the starting point. So we start at 2,650, and every hour, are we getting further away from this, from Los Angeles, or closer to, right? So when the question says write an equation to represent the distance left on the flight, that's the question, that's the y. All right, that's the question, that's the y. So distance left on flight, y. Of course, this will be slope-intercept form because we're given the slope in the word problem. So let's write it. Let's write it. All right, we have distance left on flight, y, equals, what's our slope? Well, 475 miles per hour. We need to think about this because we start with our distance traveled. And as we go 475 miles, every hour we get closer to our destination. So this 475 needs to be negative. So this is a negative 475 x per hour plus 2,650. You may say, Miss, I don't understand how you got that. Well, let's switch it around, all right? If we say y equals what we started with, which was 2,650 miles, and every hour we close that gap, right, between distance, then this is a subtraction of 475 miles per hour. And I think it'll make a little bit more sense to us. Uh-oh. There we go.